My name is Olivier Rebuffet. I am currently manager of research and development for automotive body sheets at CTEC, Constellium Technology Center. My former experience was to be head of the product development department of automotive structure in Gottmanningen, Germany. Actually, you have two types of safety. You have active safety and passive safety. Active safety is all the systems that are put in place to avoid an accident. Passive safety are all the systems to mitigate the consequence of an accident when it occurs. Aluminium plays a role to active safety. Everyone can believe that active safety is more related to electronics, sensors. You know, everyone knows the first generation of active braking system or ESC, electronic stability control, but to activate this safety, a light car helps, and aluminium contributes to make the car lighter. Aluminium contributes to make the car easier to handle, and aluminium contributes to reduce the braking distance and consequently to avoid accidents. Passive safety are all the system that we put in place to mitigate the consequence of an accident once it occurs. You have special systems that everyone knows, like seat belt, airbags. Aluminium doesn't play a role in that. But you have as well the design of the structure of the vehicle, where aluminium offers marvelous solutions. Typically, the design engineer strategy to address passive safety is to organize a rigid cage, a safe cage around the passengers with some crumple zone in the front and in the rear. And aluminium can contribute to both areas. For the rigid cage, aluminium is offering some technologies like thick gauge hot forming, tubular extrusion that are extremely adapted to prevent intrusions. It allows to involve thick and strong material at the right place and to address all the objectives of the design engineer for the rigid cage. For the crumple zone, the strategy is to organize the crush of the car with a very controlled force level. And the force level is highly dependent of the gauge of the material you use. You can use steel, you can use aluminium, that are the most popular material for crumple zone. The point is that the force is over proportional to the gauge, and it means that when you double the gauge, you triple the force. It means that aluminium can provide an excellent lightweighting for this area. Aluminium can provide 40 to 50% lightweighting for crumple zones. To protect batteries that are typically located under the passengers, under the seats of the passengers, you use the same strategy. You organize a very stiff and strong area around the cells, and you organize crumple zone on each side, typically located within the rockers of the vehicle. Here as well, aluminium offers perfect solutions. You can use thick plate to protect the batteries from the road intrusions, and you can use extrusions on each side to absorb energy in case of intrusions. In case of lateral intrusions especially. Constellium metallurgists have designed specific crash alloys with high ductility, meaning no cracks during large deformations. What does that bring? It brings that the crash will be predictable. The crash will happen exactly like numerical simulation expect it will happen. Finally, let's remind that aluminium is offering lightweighting. And lightweighting, this is less kinetic energy for the vehicles in motion, and it means a better management of the safety of everyone on the road, not only the passengers of the vehicle, but as well other vehicles, bikes, pedestrians. So lightweighting is more safety for everyone.